Simple Mail Transfer Protocol is an Internet standard for electronic mail transmission. First defined by RFC 821 in 1982, it was last updated in 2008 with the extended SMTP additions by RFC 5321, which is the protocol in widespread use today. SMTP by default uses TCP port 25. The protocol for mail submission is the same, but uses port 587. SMTP connections secured by SSL, known as SMTPS, default to port 465. While electronic mail servers and other mail transfer agents use SMTP to send and receive mail messages, user-level client mail applications typically use SMTP only for sending messages to a mail server for relaying. For receiving messages, client applications usually use either POP3 or IMAP. While proprietary systems and mail systems use their own non-standard protocols to access mailbox accounts on their own mail servers, all use SMTP when sending or receiving email from outside their own systems. History: various forms of one-to-one electronic messaging were used in the 1960s. People communicated with one another using systems developed for specific mainframe computers. As more computers were interconnected, especially in the U.S. government's ARPANET, standards were developed to allow users of different systems to email one another. SMTP grew out of these standards developed during the 1970s. SMTP can trace its roots to two implementations described in 1971, the Mailbox Protocol, whose implementation has been disputed, but is discussed in RFC 196 and other RFCs, and the SNDMSG program, which, according to RFC 2235, Ray Tomlinson of BBN invented for TENEX computers to send mail messages across the ARPANET. Fewer than 50 hosts were connected to the ARPANET at this time. Further implementations include FTP Mail and Mail Protocol, both from 1973. Development work continued throughout the 1970s, until the ARPANET converted into the modern Internet around 1980. John Postal then proposed a mail transfer protocol in 1980 that began to remove the mail's reliance on FTP. SMTP was published as RFC 788 in November 1981, also by Postal. The SMTP standard was developed around the same time as Usenet, a one-to-many communication network with some similarities. SMTP became widely used in the early 1980s. At the time, it was a complement to Unix copy program mail, which was better suited for handling email transfers between machines that were intermittently connected. SMTP, on the other hand, works best when both the sending and receiving machines are connected to the network all the time. Both use a store and forward mechanism and are examples of push technology. Though Usenet's news groups are still propagated with UUCP between servers, UUCP as a mail transport has virtually disappeared along with the bank paths it used as message routing headers. SendMail, released with 4.1 CBSD, right after RFC 788, was one of the first mail transfer agents to implement SMTP. Over time, as BSD Unix became the most popular operating system on the Internet, SendMail became the most common MTA. Some other popular SMTP server programs include Postfix, Gmail, Novell Groupwise, Exim, Novell NetMail, Microsoft Exchange Server, Sun Java System Messaging Server. Message submission and SMTP AUTH were introduced in 1998 and 1999, both describing new trends in email delivery. Originally, SMTP servers were typically internal to an organization, receiving mail for the organization from the outside, and relaying messages from the organization to the outside. But as time went on, SMTP servers, in practice, were expanding their roles to become message submission agents for mail user agents, some of which were now relaying mail from the outside of an organization. This issue, a consequence of the rapid expansion and popularity of the World Wide Web, meant that SMTP had to include specific rules and methods for relaying mail and authenticating users to prevent abuses such as relaying of unsolicited email. Work on message submission was originally started because popular mail servers would often rewrite mail in an attempt to fix problems in it, for example, adding a domain name to an unqualified address. This behavior is helpful when the message being fixed is in initial submission, but dangerous and harmful when the message originated elsewhere and is being relayed. Cleanly separating mail into submission and relay was seen as a way to permit and encourage rewriting submissions while prohibiting rewriting relay. As spam became more prevalent, it was also seen as a way to provide authorization for mail being sent out from an organization, as well as traceability. This separation of relay and submission quickly became a foundation for modern email security practices. As this protocol started out purely ASCII text-based, it did not deal well with binary files, or characters in many non-English languages. Standards such as multi-purpose Internet mail extensions were developed to encode binary files for transfer through SMTP. Mail transfer agents developed after SendMail also tend to be implemented 8-bit clean, so that the alternate just send 8 strategy could be used to transmit arbitrary text data via SMTP. Mojibik was still a problem due to differing character set mappings between vendors, although the email addresses themselves still allowed only ASCII. 8-bit clean MTAs today tend to support the 8-bit MIME extension, permitting binary files to be transmitted almost as easily as plain text. Recently the SMTP UTF-8 extension was created to support UTF-8 text, allowing international content and addresses in non-Latin scripts like Cyrillic or Chinese. Many people contributed to the core SMTP specifications, among them John Postal, Eric Ullman, Dave Crocker, Ned Freed, Randall Gellens, John Clenson, and Keith Moore. Mail processing model. Email is submitted by a mail client to a mail server using SMTP on TCP port 587. Most mailbox providers still allow submission on traditional port 25. From there, the MSA delivers the mail to its mail transfer agent. Often, these two agents are just different instances of the same software launched with different options on the same machine. Local processing can be done either on a single machine, or split among various appliances. In the former case, involved processors can share files. In the latter case, SMTP is used to transfer the message internally, with each host configured to use the next appliance as a smart host. Each process is an MTA in its own right. That is, an SMTP server. The boundary MTA has to locate the target host. It uses the domain name system to look up the mail exchanger record for the recipient's domain. The returned MX record contains the name of the target host. The MTA next connects to the exchange server as an SMTP client. Once the MX target accepts the incoming message, it hands it to a mail delivery agent for local mail delivery. An MDA is able to save messages in the relevant mailbox format. Again, mail reception can be done using many computers or just one. The picture displays two nearby boxes in either case. An MDA may deliver messages directly to storage, or forward them over a network using SMTP, or any other means, including the local mail transfer protocol, a derivative of SMTP designed for this purpose. Once delivered to the local mail server, the mail is stored for batch retrieval by authenticated mail clients. Mail is retrieved by end-user applications, called email clients, using Internet Message Access Protocol, a protocol that both facilitates access to mail and manages stored mail, or the Post Office Protocol, which typically uses the traditional MBOX mail file format or a proprietary system such as Microsoft Exchange Outlook or Lotus Notes Domino. Mail clients may use either method, but the retrieval protocol is often not a formal standard. SMTP defines message transport, not the message content. Thus, it defines the mail envelope and its parameters, such as the envelope sender, but not the header nor the body of the message itself. 10 Sautom and Principe Dobras and RFC 5321 define SMTP, while 11 Sautom and Principe Dobras and RFC 5322 define the message, formerly referred to as the Internet Message Format. Protocol Overview: SMTP is a connection-oriented, text-based protocol in which a mail sender communicates with a mail receiver by issuing command strings and supplying necessary data over a reliable order data stream channel, typically a transmission control protocol connection. An SMTP session consists of commands originated by an SMTP client and corresponding responses from the SMTP server so that the session is opened, and session parameters are exchanged. A session may include 0 or more SMTP transactions. An SMTP transaction consists of 3 command reply sequences. They are, mail command, to establish the return address, aka return path, reverse path, bounce address, MFROM, or envelope sender. This is the address to which bounce messages should be sent. RCPT command, to establish a recipient of this message. This command can be issued multiple times, one for each recipient. These addresses are also part of the envelope. Data to signal the beginning of the message text. The content of the message, as opposed to its envelope. It consists of a message header and a message body separated by an empty line. Data is actually a group of commands, and the server replies twice, once to the data command proper, to acknowledge that it is ready to receive the text, and the second time after the end of data sequence, to either accept or reject the entire message. Besides the intermediate reply for data, each server's reply can be either positive or negative. Negative replies can be permanent or transient. A reject is a permanent failure by an SMTP server. In this case, the SMTP client should send a bounce message. A drop is a positive response followed by message discard rather than delivery. The initiating host, the SMTP client, can be either an end-user's email client, functionally identified as a mail user agent, or a relay server's mail transfer agent, that is an SMTP server acting as an SMTP client, in the relevant session, in order to relay mail. Fully capable SMTP servers maintain queues of messages for retrying message transmissions that resulted in transient failures. AMUA knows the outgoing mail SMTP server from its configuration. An SMTP server acting as client, that is relaying, typically determines which SMTP server to connect to by looking up the MXDNS resource record for each recipient's domain name. Conformant MTAs fall back to a simple A record in case no MX record can be found. Relaying servers can also be configured to use a smart host. An SMTP server acting as client initiates a TCP connection to the server on the well-known port designated for SMTP, port 25. MUAs should use port 587 to connect to an MSA. The main difference between an MTA and an MSA is that SMTP authentication is mandatory for the latter only. SMTP versus Mail Retrieval, SMTP is a delivery protocol only. In normal use, mail is pushed to a destination mail server as it arrives. Mail is routed based on the destination server, not the individual user, to which it is addressed. Other protocols, such as the Post Office Protocol and the Internet Message Access Protocol, are specifically designed for use by individual users retrieving messages and managing mailboxes. To permit an intermittently connected mail server to pull messages from a remote server on demand, SMTP has a feature to initiate mail queue processing on a remote server. POP and IMAP are unsuitable protocols for relaying mail by intermittently connected machines. They are designed to operate after final delivery, when information critical to the correct operation of mail relay has been removed. Remote message queue starting. Remote message queue starting is a feature of SMTP that permits a remote host to start processing of the mail queue on a service so it may receive messages destined to it by sending the turn command. This feature, however, was deemed insecure and was extended in RFC 1985 with the ETRN command, which operates more securely using an authentication method based on domain name system information. On-demand mail relay. On-demand mail relay is an SMTP extension standardized in RFC 2645 that allows an intermittently connected SMTP server to receive email queued for it when it is connected. Internationalization. Many users whose native script is not Latin-based have had difficulty with the Latin email address requirement. Often this leads to meaningless, but easy-to-type, locale addresses. RFC 6531 was created to solve that problem, providing internationalization features for SMTP, the SMTP UTF-8 extension. RFC 6531 provides support for multi-byte and non-ASCII characters in email addresses, such as pelacopyright@live.com, III to the first I1/4 registered trademark at I plus or minus III micron I to the first I³ I1/4 plus or minus III to the first I1/4 registered trademark, and E micron E at E micron E micron E. Current support is limited, but there is strong interest in broad adoption of RFC 6531 and the related RFCs in countries like China that have a large user base where Latin is a foreign script. Outgoing Mail SMTP server. An email client needs to know the IP address of its initial SMTP server, and this has to be given as part of its configuration. This server will deliver outgoing messages on behalf of the user. Outgoing mail server access restrictions. Server administrators need to impose some control on which clients can use the server. This enables them to deal with abuse, for example spam. Two solutions have been in common use. In the past, many systems imposed usage restrictions by the location of the client, only permitting usage by clients whose IP address is one that the server administrators control. Usage from any other client IP address is disallowed. Modern SMTP servers typically offer an alternative system that requires authentication of clients by credentials before allowing access. Restricting access by location. Under this system, an ISP's SMTP server will not allow access by users who are outside the ISP's network. More precisely, the server may only allow access to users with an IP address provided by the ISP, which is equivalent to requiring that they are connected to the Internet using that same ISP. A mobile user may often be on a network other than that of their normal ISP, and will then find that sending email fails because the configured SMTP server choice is no longer accessible. This system has several variations. For example, an organization's SMTP server may only provide service to users on the same network, enforcing this by firewalling to block access by users on the wider Internet. Or the server may perform range checks on the client's IP address. These methods were typically used by corporations and institutions such as universities, which provided an SMTP server for outbound mail only for use internally within the organization. However, most of these bodies now use client authentication methods, as described below. By restricting access to certain IP addresses, server administrators can readily recognize the IP address of any abuser. As it will be a meaningful address to them, the administrators can deal with a rogue machine or user. Where a user is mobile, and may use different ISPs to connect to the Internet, this kind of usage restriction is onerous, and altering the configured outbound email SMTP server address is impractical. It is highly desirable to be able to use email client configuration information that does not need to change. Client authentication. Modern SMTP servers typically require authentication of clients by credentials before allowing access, rather than restricting access by location as described earlier. This more flexible system is friendly to mobile users and allows them to have a fixed choice of configured outbound SMTP server. Open Relay. A server that is accessible on the wider Internet and does not enforce these kinds of access restrictions is known as an open relay. This is now generally considered a bad practice worthy of blacklisting. Ports. Server administrators choose whether clients use TCP port 25 or port 587, as formalized in RFC 6409, for relaying outbound mail to an initial mail server. The specifications and many servers support both. Although some servers support port 465 for legacy secure SMTP in violation of the specifications, it is preferable to use standard ports and standard ESMTP commands according to RFC 3207 if a secure session needs to be used between the client and the server. Some servers are set up to reject all relaying on port 25, but valid users authenticating on port 587 are allowed to relay mail to any valid address. Some Internet service providers intercept port 25, redirecting traffic to their own SMTP server regardless of the destination address. This means that it is not possible for their users to access an SMTP server outside the ISP's network using port 25. Some SMTP servers support authenticated access on an additional port other than 587 or 25 to allow users to connect to them even if port 25 is blocked, but 587 is the standardized and widely supported port for users to submit new mail. Microsoft Exchange Server 2013 SMTP can listen on ports 25, 587, 465, 475, and 2525, depending on server role and whether roles are combined on a single server. Ports 25 and 587 are used to provide client connectivity to the front-end transport service on the client access server role. Ports 25, 465 and 475 are used by the mailbox transport service. However, when the mailbox role is combined with the CAS role on a single server, port 2525 is used by the mailbox role for SMTP from the CAS front-end transport service, while CAS continues to use port 25. Port 465 is used by the mailbox transport service to receive client connections proxied by the CAS role. Port 475 is used by the mailbox role to communicate directly with other mailbox roles, transferring mail between the mailbox transport submission service and the mailbox transport delivery service. SMTP transport example. A typical example of sending a message via SMTP to two mailboxes located in the same mail domain is reproduced in the following session exchange. After the message sender establishes a reliable communications channel to the message receiver, the session is opened with a greeting by the server, usually containing its fully qualified domain name, in this case smtp.example.com. The client initiates its dialog by responding with a HELO command identifying itself in the command's parameter with its FQDN. S220 smtp.example.com ESMTP postfix, C, HELO relay.example.org, S250 hello relay.example.org, I am glad to meet you, C, mail from, bob@example.org, S250 awk, C, RCPTTO, alice@example.com, S250 awk, C, RCPTTO, theboss@example.com, S250 awk, C, data, S354N data with CRLF. CRLF, C, from Bob example bob@example.org, C, to Alice example alice@example.com, C, CC theboss@example.com, C, date Tuesday 15 January 2008 16:02 and 43 seconds -0500, C, subject test message, C, hello Alice. C, this is a test message with 5 header fields and 4 lines in the message body. C, your friend, C, Bob, C. S, 250 awk, queued as 12,345, C, quit, S, 221 by, the server closes the connection. The client notifies the receiver of the originating email address of the message in a mail from command. In this example, the email message is sent to 2 mailboxes on the same SMTP server, one each for each recipient listed in the to and CC header fields. The corresponding SMTP command is RCPT2. Each successful reception and execution of a command is acknowledged by the server with a result code and response message. The transmission of the body of the mail message is initiated with a data command after which it is transmitted verbatim line by line and is terminated with an end of data sequence. This sequence consists of a new line, a single full stop, followed by another new line. Since a message body can contain a line with just a period as part of the text, the client sends 2 periods every time a line starts with a period. Correspondingly, the server replaces every sequence of 2 periods at the beginning of a line with a single one. Such escaping method is called dot stuffing. The server's positive reply to the end of data, as exemplified, implies that the server has taken the responsibility of delivering the message. A message can be doubled if there is a communication failure at this time, for example due to a power shortage. Until the sender has received that 250 reply, it must assume the message was not delivered. On the other hand, after the receiver has decided to accept the message, it must assume the message has been delivered to it. Thus, during this time span, both agents have active copies of the message that they will try to deliver. The probability that a communication failure occurs exactly at this step is directly proportional to the amount of filtering that the server performs on the message body, most often for anti-spam purposes. The limiting timeout is specified to be 10 minutes. The quit command ends the session. If the email has other recipients located elsewhere, the client would quit and connect to an appropriate SMTP server for subsequent recipients after the current destination, S, had been queued. The information that the client sends in the HELO and mail from commands are added as additional header fields to the message by the receiving server. It adds a received and return path header field, respectively. Some clients are implemented to close the connection after the message is accepted, so the last two lines may actually be omitted. This causes an error on the server when trying to send the 221 reply. Optional extensions. Although optional and not shown in this example, many clients ask the server for the SMTP extensions that the server supports, by using the EHLO greeting of the extended SMTP specification. Clients fall back to HELO only if the server does not respond to EHLO. Modern clients may use the eSMTP extension keyword size to query the server for the maximum message size that will be accepted. Older clients and servers may try to transfer excessively sized messages that will be rejected after consuming network resources, including connect-timed and network links that is paid by the minute. Users can manually determine in advance the maximum size accepted by eSMTP servers. The client replaces the HELO command with the EHLO command. 220 smtp2.example.com eSMTP postfix, c. ehlobob.example.org, s250-smtp2.example.com hellobob.example.org, 192.0.2.201, s250 size 14,680,064, s250 pipelining, s250 help. Thus smtp2.example.com declares that it will accept a fixed maximum message size no larger than 14,680,064 octets. Depending on the server's actual resource usage, it may be currently unable to accept a message this large. In the simplest case, an eSMTP server will declare a maximum size immediately after receiving an EHLO. According to RFC 1870, however, the numeric parameter to the size extension in the EHLO response is optional. Clients may instead, when issuing a mail from command, include a numeric estimate of the size of the message they are transferring, so that the server can refuse receipt of overly large messages. Security and spamming. The original SMTP specification did not include a facility for authentication of senders. Subsequently, the SMTP-AUTH extension was defined by RFC 2554. eSMTP provides a mechanism for email clients to specify a security mechanism to a mail server, authenticate the exchange, and negotiate a security profile for subsequent message transfers. Microsoft products implement the proprietary secure password authentication protocol through the use of the SMTP-AUTH extension. However, the impracticality of widespread SMTP-AUTH implementation and management means that email spamming is not and cannot be addressed by it. Modifying SMTP extensively, or replacing it completely, is not believed to be practical, due to the network effects of the huge installed base of SMTP. Internet Mail 2000 was one such proposal for replacement. Spam is enabled by several factors, including vendors implementing MTAs that are not standards compliant, which make it difficult for other MTAs to enforce standards, security vulnerabilities within the operating system that allow spammers to remotely control end-user PCs and cause them to send spam, and a lack of intelligence in many MTAs. There are a number of proposals for sideband protocols that will assist SMTP operation. The Anti-Spam Research Group of the Internet Research Task Force is working on a number of email authentication and other proposals for providing simple source authentication that is flexible, lightweight, and scalable. Recent Internet Engineering Task Force activities include MARID leading to 2 approved IETF experiments in 2005, and domain keys identified Mail in 2006. In 2012, a group of organizations proposed a new specification, called DMARC, to reduce email abuse and spoofing. Implementations. Related requests for comments. RFC 1123 Euro requirements for Internet hosts Euro application and support, RFC 1870 Euro SMTP service extension for message size declaration, RFC 2505 Euro anti-spam recommendations for SMTP MTAs, RFC 2920 Euro SMTP service extension for command pipelining, RFC 3030 Euro SMTP service extensions for transmission of large and binary MIME messages, RFC 3207 Euro SMTP service extension for secure SMTP over transport layer security, RFC 3461 Euro SMTP service extension for delivery. Status notifications, RFC 3463 Euro enhanced status codes for SMTP, RFC 3464 Euro an extensible message format for delivery status notifications, RFC 3798 Euro message disposition notification, RFC 3834 Euro recommendations for automatic responses to electronic mail, RFC 4952 Euro overview and framework for internationalized email, RFC 4954 Euro SMTP service extension for authentication, RFC 5068 Euro email submission operations, access and accountability requirements, RFC 5248, a registry for SMTP. Enhanced Mail System Status Codes, RFC 5321 Euro the Simple Mail Transfer Protocol, RFC 5322 Euro Internet Message Format, RFC 5336 Euro SMTP extension for internationalized email addresses, RFC 5504 Euro downgrading mechanism for email address internationalization, RFC 6409 Euro message submission for mail, RFC 6522 Euro the multi-part report content type for the reporting of mail system administrative messages, see also, bounce address, email encryption, ident, POP before SMTP/SMTP after POP, sender policy. Framework, variable envelope return path, notes. References, Hughes, L. Internet Email Protocols, Standards and Implementation. Artec House Publishers. ISBN A0-89006-939-5, Hunt, C. Send Mail Cookbook O'Reilly Media. ISBN A0-596-00471-0, Johnson, K. Internet Email Protocols, A Developer's Guide. Addison Wesley Professional. ISBN A0-201-43288-9, Loshin, P. Essential Email Standards, RFCs and Protocols Made Practical. John Wiley & Sons. ISBN A0-471-34597-0, Rotom, J. Programmer's Guide to Internet Mail, SMTP, POP, IMAP, and LDAP. Elsevier. ISBN A1-55558-212-5, Wood, Deprogramming Internet Mail. O'Reilly. ISBN A1-56592-479-7, External links, email address Internationalization IETF Working Group.